So today we are going to look at distance and how distance works on the coordinate plane. So let's say I have a point A there, and I also have point B. I'm going to make this a little bit bigger. There we go. So I have point A and point B, and I want to know the distance between them. There's really two ways that I can do this. If I just look at the number, that's not going to be right because it doesn't start at 0. This is not 3 units long, right? Because it doesn't start at 0. So I have two options. I can either count 1, 2, 3, 4, 5, 6. Okay. Or, so I know that it's 6 units long. Or I can look at this and I can subtract these numbers. I can say, okay, we're going to have 3 minus a -3. So we're going to figure out the distance between these two, and the distance is a difference. 3 minus a -3, I'm taking away -3, which is the same thing as adding -3, which is 6, which gives us the exact same number as if we had counted. Right? So that's a horizontal one. Let's look at a vertical one. We're going to do the same thing. So I can either count 1, 2, and have a distance of 2, or I can subtract 4. This one's at 4 minus, what's the difference here? 4 minus 2 is, and we're not surprised, it's going to be the same answer. So these are pretty easy and pretty straightforward because they're along the vertical and horizontal lines. But what if we have 2 points that aren't along a vertical and horizontal line? What if we have 2 points like this and they're going to cut across? So I'm going to make a line from B to A. And so your gut might say, well, I can do this. I can just count how many sections it crosses. It crosses 1, 2, 3, 4, 5, 6. It crosses 6 sections. So this is 6 units long. But that's not really right. Like the part of this section that it crosses is a lot smaller than the part of this section that it crosses. And this is 1 unit. How do I know how many of those are along this line? I can't just count how many sections it crosses because that really doesn't give me an accurate distance. If I lived in point B and was going to point A and I wanted to walk there, I want to know the distance, and it's not going to be 6 just because I'm crossing over 6. So how would we figure this out? Because I don't have the ability to pick up this little guy and measure to be able to see how many units there are. I can't digitally do that. There's no way. If I had a ruler, I could whip out my ruler and use that, but we're not going to do that. There is another way. So I'm looking at this and I see and I notice that I've got, I'm going to do this with the line thing again. I'm going to do it in purple. I've got this line right there. And I've got this line right here. And when I put all these lines together, I can see that I have a right triangle. Now you might be saying to yourself, nobody told us it's a right triangle. You have to tell us it's a right triangle to be able to use the rules of right triangles, right? We know that. But we also know that when you have a coordinate plane, which we have the coordinate plane here, all of these grid markers meet at right angles. That's one of the definitions of the coordinate plane, is that they meet at right angles. So we know that this angle right here is the right angle. So this makes this a right triangle. And since it's a right triangle, we can use the Pythagorean theorem on it. So let's do that. Let's use the Pythagorean theorem on this. I can call this A, and I can call this B, and I can call the hypotenuse C. This is always going to be the sleepy slidey slope is going to be the hypotenuse. It's the part of the triangle that is not touching the right angle. Here's the right angle right there. So how long is A? Well, I can count this one. 1, 2. A is 2. So 2 squared plus, let's count B. 1, 2, 3, 4, 5, 6. So B is 6. 6 squared. Now you might be tempted to say that b is 8. Because look, there's that 8 right there. But b does not start at 0. B starts at 2. We can say we have 8 minus 2 equals 0, which it does. No, it doesn't. It equals 6. Do you like how I saved that? 8 minus 2 equals 6, or we can just count 1, 2, 3, 4, 5, 6. To be honest with you, on ones that are this size, I usually just count, okay? So we know that 2 squared plus 6 squared equals c squared. Well, what is c? Let's do the math. So 2 squared is 4. 6 squared is 36 equals c squared. 4 plus 36 is 40. What does c equal? Well, I need to take the square root of 40. Now, I do not know what the square root of 40 is. So I'm going to hop over here. I'm going to go 40 square root 6.32. Looks like what it is. So c equals 6.32. Now, if we had just said, it equals 6, we would have been wrong. It crossed 6 squares, but it's actually 6.32 units long. Whatever one of these squares is, if the square is a mile, it's 6.32 miles. If the square is a foot, it's 6.32 feet. If the square is a centimeter, it's 6.32 centimeters. But whatever it is, it's 6.32 of them. Okay, let's do another one. Now I'm not doing ones, I'm doing ones that were originally on your assignment that I took off to make your assignment shorter. So I'm not doing any on your actual assignment today. Just be aware of that, okay? So let's see if we can figure out the distance between A and B. Let's draw our triangle because we know that we can make a right triangle out of this. So let's find a line. There is our hypotenuse. And then we need the 2 lines of our triangle. So I'm going to go down. Now, would I get a different answer if I went up and over instead? Nope, I would not. Let's go up and over instead. I'm going to get the same answer no matter how, because it's going to be the same horizontal distance and the same vertical distance. It's just how the triangle is oriented. So let's do this math. So we know that we're going to have an equation. We know we have a right triangle right here. We know it's a right triangle because we know that this is a right angle on the coordinate plane. We know that it's going to be a squared plus b squared equals c squared. So what is a, what is b, and what is c? Well, I don't know what c is. I know that c crosses through three of these sections, but I do know that c is not a 3 because these sections are way longer than this side. So let's count. We have 1, 2, 3. So this is, if this is a and this is b, I'm going to have a is 3. So 3 squared plus, let's b, 1, 2, 3. 3 squared equals c squared. Well, what's 3 squared? 3 squared is 9. 3 squared is 9. Equals c squared. 9 plus 9 is 18. 18 equals c squared. Let's try to figure out what c is. Square root of c squared is c. Square root of 18, I don't know. So we're going to hop over to our calculator and say 18, what's the square root of it? 4.24. Okay, so c is 4.24. Let's see if this passes the does it make sense test. If this is 4, oh wait, if that one is the hypotenuse, I'm going to actually make it in red. So we're going to have 4.24 4 is the hypotenuse. Does this make sense? Well, it's 3 on this side, it's 3 on this side, it's a little more than 4 on this side. So yeah, it makes sense that that would work. I'm going to go ahead and do one more for you, and then I think we're going to go ahead and be done. This is really a pretty straightforward assignment and very straightforward concept. It's just how to apply the Pythagorean theorem on the coordinate plane. So we've got A and B. A is right here. B is up here. Oh, I've been making the hypotenuse purple or red. Let's keep making it red. So A is there, B is there. And let's figure out what the sides are. So there's the side. There's this side. Trying to get it perfect. All right, so what is this hypotenuse? Okay. Well, we first need to figure out what A and B are. So I'm going to call this one A. I'm going to call this one B. And this one, the hypotenuse, has to be C. So what's A going to be? 1, 2, 3, 4, 5. So A is 5. B is 1, 2, 3, 4, 5, 6. B is 6. So what does C equal? So A squared, I am starting up a little bit high or a little bit low. I'm going to go higher. A squared plus B squared equals C squared. A is 5, so we have 25 plus, oh, I skipped a step. That's naughty. 5 squared, I'm jumping the gun here, guys, plus 6 squared equals C squared. So I already told you what 5 squared equals. If you're paying attention, 5 squared is 25. C squared is 36. So 6 squared is 36. C squared, we don't know C squared. 6 squared is 36. Equals C squared. 25 plus 36 is 61. 61 equals C squared. What does C equal? Well, the square root of C squared equals C. And if I square root one side, I need to square root the other side. So the square root of 61, I don't know. Let's find out. Square root of 61 is 7.81. So this distance is 7.81. So let's see if that makes sense. Does it make sense that this is 7.81 on this hypotenuse here? Well, this is 5. This is 6. Yeah, that makes sense that this would be 7.81. So I'm going to say that 7.81 equals C. So I think that we've gotten you off to a pretty good start. This is really pretty basic as far as the Pythagorean theorem goes. We're just extending it to the coordinate plane where we know that we have right angles. And let me know if you have any questions. Bye.